Okay, well, first of all, thank you for the SUMO community for having this opportunity and participating in your user conference. As you said, Peter, it's quite strange, but well, we have to take the positive things. We don't have to travel too much, so we can do everything virtually with the inconvenience that it creates. Well, my speak is focused on well, this quite generic title, Emerging Mobility Trends and the Role of Transport Simulation Models. The goal of this presentation is to try to promote the debate and try to be critic in terms of what we are providing as transport model. This speak, I try to be impartial in terms of non having too much bias in that case to AIMSUN that I'm representing, but I think the comments that I'm going to express during this presentation, I think are quite generic, and I think also could be extrapolated, not only microsimulation, in general transport simulation models. And well, I hope you enjoy. I create a questions, so I'm going to share with you these questions through an interactive way. The name is Slido. So let's see how it works. Just to give that's the possibility to give us your feedback. Okay, so as Peter mentioned, I have more than 20 years experience on developing transport simulation models. So we start at the university in our research groups, Polytechnical University of Catalonia. And I remember that we start on developing this microscopic simulation. But in 1997, we decided to create a spin-off. So we create a company, and now the company is let's say developing and commercializing this transport simulation model that integrates different approach. So not only microscopic simulation, also mesoscopic and microscopic. Okay, so I start with this slide because there is a kind of widely acknowledged, that is the concept of sustainable urbanization. Okay, the rapid technological developments such as automation, the implications in the social transformations or shared economy seem to accelerate the pace of urban mobility changes. And therefore there is a need for response from the authorities in charge of its management. In order to tackle this challenge and ensure the competitive and resource efficient urban mobility, public authorities hold the responsibility of managing and regulating urban transport systems. They involved a continuous effort to cope with the numerous externalities that transport entails. Many of the actions that the local governments and the metropolitan entities carry out are devoted to mitigating the impacts of the usage of the private cars, promoting to modal shift towards more sustainable options. So this is, let's say, quite acceptable statement. For example, in Barcelona, and this slide comes from, is inspired in Barcelona, Barcelona Urban Mobility Plan oversees the introduction of superblocks. The plan is to take urban surface space, now devoted to private cars, and open this space to a multiple use: walking, cycling, socializing. The only way to do this change is exclude the vehicle traffic, the private vehicle traffic, sorry, and change the land use definition. For instance, in the Barcelona case, they plan to reduce the road network for the private cars up to 50%. So from 912 kilometers to 355 kilometers. And in terms of accessibility, the citizens will be able to access to increase this 67 to length in terms of linear space. When Barcelona planned this change, or this urban mobility plan, at that time, the disruptive technology that now is here, and all trends related to mobility, so services, technology, etc., was not there. So in that case, the situation in Barcelona, they are applying this urban plan, mobility plan. They already set some pilots inside of the city, but recently, the last year, they did an interview of how to deal with micromobility. In that case, the electric scooters, they realized that the electric scooters demands came not from private cars, came from public transport or the regular public transport, bus and metro. So in that case, they have to reconsider a lot of redefined policies, redefined the plan. So it's something that, well, at that time, they didn't consider, and today they are considering. So this is an example. So in general, we're using transport models. We're using a transport model that, well, represents a computer-based representation of the mobility, in that case, the movement of the people and goods. And these transport models has to support, to help the design, the operation of a transport system. Traditionally, there are two completely, sometimes isolated worlds, transport planning and transport operation, traffic management, where the type of tools used sometimes were isolated. So we have an axis that represents the demands, so a static demand with a macroscopic view of the infrastructure. And traffic management and traffic operation required a dynamic demands with a detailed information of the infrastructure with some completely different models. So this is the reason why we have different type of approach, static models or macroscopic models, up to microscopic models, and in between mesoscopic models. So in general, traditionally, the concept of static and dynamic traditionally is long-term analysis and short-term analysis. The transport planning is for understanding how transport conditions will change in the future, for understanding how transport conditions will change due to the fact that social economic changes, new facilities, new urban plans, etc. The transport management is very short term, so is today what will be the effect of one specific demand in this specific infrastructure. So how I can manage this capacity of my infrastructure, how can I optimize the current capacity. So the needs of different models was there, is still there. And normally there is an analysis in cascade that transport planning derive traffic demands, and then this traffic demand is an input for the dynamic models, such microscopic simulation models. The question is, well, let's how these models evolve, how these models grow up. Well, I remember that the transport simulation models, I'm talking about, for instance, AIMSUN Next, also VSIM, Paramix, and SUMO, I think, if I remember correctly, was later, but we had exactly the same schema. Some research groups at the university set up a microsimulation model. At the end, this microsimulation model end up in a company. And now we have different products with different competitions. But the trigger of this necessity to create different microsimulation models was the need to evaluate the new systems. At that time was ITS, Intelligent Transport System, right? I remember that during the 80s and the 90s, the need of evaluation of all ITS was necessary, and this was the reason to have these microsimulation models. For example, well, the Gibbs model, the car following, was in 1981, if I remember correctly. So in that case, the ITS and the need to evaluate the ITS was the cause to having new transport simulation models that appears to solve these requirements. Another aspect to remark is, so far, the stakeholders were the road operators and the public administration. So the road operators and the public administration had or have policies or management tools to increase the capacity, if this is possible, optimize the capacity, but always is focused on the supply to modulate or limit the demand. For instance, define low emission zones, congestion pricing schemas, expressways. So the idea is how to manage the infrastructure in order to optimize the capacity. That means reduction of the delays, but in an indirect way. So there is no interaction between the user and in that case the supply. So when the user drives, it receives the restrictions according the policy implemented by each public authority or road operator. So in general, we went from static models to dynamic models. So, and this is I don't know how it's going to work. So I don't know if you have access to this slide of questions, because for me, for me, there's a basic question, so I can share with you if I can. Sorry. Here. I don't know if you can see, you can't scan the QR code. If not, you can join slido.com with this number of Paul. And the question that I try to ask you is, I'm not talking about the future. I'm not going to talking about the new mobility schemas. I'm talking to the past. So the traditional use of transport models. So what is the percentage of use cases that were well supported by the current transport models? Think on use cases, for example, safety, resilience, I don't know. So I'm not asking a concrete number, just so a lot of people, that represents the 50%. So that means the 50%, the 50%, the transport models couldn't provide an answer. Interesting. Okay. And, well, what are the current limitations of the traffic simulation models in the use cases that were not able to solve? So what are the drawbacks, the weakness? Accuracy. Well, according to that, it seems that the data is a key answer. Human behavior, it seems another. Computing power, realism. So trying to summarize your questions or your answer, it seems that the data it's a key question, and it seems the human behavior. I agree, and especially for the data. Recently, there are different initiatives to validate the traffic simulation models, in that case, microscopic simulation models using trajectory data. I'm aware of two initiatives, one in the US. And for me, the question is, all transport simulation model was designed, was implemented for solving a specific use cases. And at the end was try to model an average human behavior, where the validation was and is using aggregated data or macroscopic variables such as flow, density, speed. For that purpose, I think the current transport models did and are doing a very good job. For me, the problem, and it has been stressed in your answer, is, well, there is no realism, but there is no realism for what? For instance, I think that there is no realism to model the safety aspects, right? I remember last year during the TRB conference, there is a debate about whether the simulation models could deal with safety aspects. Why is not, or I think that is not strictly possible to do the safety analysis, right? One reason is the data. So we cannot collect enough data in order to have a better human driver behavior, and also the vehicle dynamics that are factors that affects the safety. Another example that we are providing some answer is related to emissions. It means also inside of the emission model, there is a lot of debates how accurate are the emission models. But supposedly that the emission models are correct, even the simulation models, the microscopic models, cannot deal with emission models properly, because sometimes there is not the vehicle dynamics, and the vehicle dynamics is an important aspect. So in that case, well, when we're evaluating emissions, maybe we're evaluating the trends, not the absolute value. We are comparing a scenario A with a scenario B, but at the end, we are analyzing the difference between two scenarios, because maybe the outcome of emission model in a microsimulation model is not accurate enough, right? I hope, well, is the line that you express in your answers. And now, what's going on? So what are the new trends? How we are going to solve the problems? Well, I think now it's much more complex. So the complexity has increased. There is also a governance problem because the number of stakeholders has increased in order to take decisions in terms of mobility. There are also technological aspects, autonomous vehicles, connectivity, etc. And of course, social aspects. So all these aspects are creating a big uncertainty that, in that case, transport simulation models has to, let's say, give and provide an answer. Let's see. On the right, I put just this as an example that in the case of San Francisco, these ride-sharing companies increase the congestion in the city of San Francisco. In that case, it's an example of governance. It means in that case, the public authority, the road authority, didn't have any tool or any mechanism to, let's say, add restrictions to the ride-sharing companies, to the fleet, the composition of the fleet, so the reduction of the number of vehicles, that in order to optimize what could be the better option at the end in terms of the system, in terms of reduce the degree of the congestion. Okay, so so the idea is, well, how the traffic simulation models has to evolve, because the previous approach, we have the planning and operational, we have this static view and this dynamic view of the mobility. I think now it's more complex, basically because the stakeholder has increased. So now we have technology providers that has an effect. So, and so far is completely uncertainty. For instance, autonomous vehicles. What will be the future scenario? There are service providers, the public administration, the road operators, but also entering in the electric vehicles, we add other stakeholders, that is the stakeholders related to charging points and the grid operators. At the end, we have exactly the same problem as before, but increasing the complexity and increasing the different type of requirements. For instance, the technology providers are putting a lot of emphasis on safety. They are developing sensors, they are developing algorithms to anticipate, algorithms to planning motion, etc. And the main goal is safety, 0% fatalities. However, this could imply for the public administration and road operators, could imply a reduction of the performance of the network, of the system. That means increase the congestion, increase the emissions, increase the noise, right? Or service providers. So there is should be governments or regulations related how we can provide a specific service if there is the limitations, etc. So at the end, the interactions and the relationship between the different stakeholders is much more complex as before. And again, let's go to Slido. The last question. So in order to, let's say, fulfill the requirements of all the stakeholders and answer all the questions that are they asking, well, what is necessary to do in terms of developments or research? What's your opinion? For example, combination of data-driven models plus simulation models. The concepts of big data, disaggregated demand. Well, according to your answers, I think you trust a lot with data, have access to this data. So in that case, everything related to big data, data fusion, connectivity, Internet of Things, ITS is there. And on the other hand, I can distinguish, well, more realistic traffic models. In that case, more human behavior model, or better human behavior model, if I understood correctly. What I don't understand is SUMO in administration. I don't think that could be a research line, but I can understand. I think, well, your answers, I think it's quite aligned what's in this slide, that it's, there is no an implicit order. Means my intention was not to say what is in the first position, what is the second. It's just a compendium of different aspects that we need. One important thing, data collection. I completely agree. It means the opportunity to collect data, a part of the privacy things. Of course, this is also another thing, but assuming that the data collection is there, will be there, and we can exploit a lot in order to represent or have better representation of the human or the travel patterns and also the human behaviors. Again, I'm not claiming that it's going to solve everything. and there is a privacy issues that is a big concern everywhere, right? This is one aspect. This data collection, for me, is driving to models where we have more granularity in terms of the demand. We are going to deal with disaggregated demand, and for me, it's yes or yes. There is also aspects that we cannot pretend, also in the future, we cannot pretend that a single model can answer all the questions. So for me, the combination of different models, methods will be there. For instance, the combination of AI plus simulation-based models, I think opens a window where the goal should be an improvement, a lot of improvement related to the traffic models. Aspects that are sometimes crucial is whether when we have a good representation of a behavior model, doesn't matter whether it's human or not, how transferable is. Means we can pretend that a simulation model is universal, that we can pretend that this simulation model or behavioral model works in US, works in Germany, works in Spain, works in India. So all these aspects at the end is an increase of the uncertainty. This uncertainty is greater than before. There are aspects that, for instance, the technology, we cannot plan or determine when we'll be ready, right? We have prototypes, we have some specific use case, but when this technology will be ready for everybody, right? So that creates a lot of uncertainty. So the penetration rate, okay? And this uncertainty is basically based on this change of the society, right? So all these challenges is something that I'm not pretending to solve. So I think step by step, and the community has to address and has to, well, to go step by step and project by project and try to see the benefits of one new methodology, a new type of data, etc., etc. I think we are on the way. So I was surprised when I checked the SUMO user conference. I like the title, From Traffic Flow to Mobility Modeling. So I think it's exactly what we're discussing here. And here in the call for papers that you propose, you are covering these aspects that I mentioned, right? So autonomous driving, logistics, so the integration of the goods and people, connectivity, e-mobility. So I think this is a line. So we are there. For instance, we are covering other type of requirements. So the traffic simulators are used now for the evaluation of the other system or autonomous vehicles stacks. So we have integrated traffic simulation that recreates this virtual environment of a city, and then the car drives into getting the reality according to their sensors, etc. Or the use of the traffic simulation models as a core for the decision support system for traffic management. So at the end, there is plenty of open questions, is plenty of open fields that we need to go step by step. So our contribution to that, trying to be very modest, I'm going to just illustrate some 4 European projects that we are involved. where the traffic transport model and the simulation plays a role. Okay, so it's Levitate, Save Up, Harmony, and Momentum. Very quick. So Levitate Project. Levitate Project, the main, the goal is to develop a policy support tool. This evaluation framework is to assess the impact of the connected and automated transports. So a high level, a policy level, sorry, I don't know why it changes. In that case, AIMSUN is helping to design the use cases that will be used in the simulation assessment of the system impacts that will be then scale up to this policy support tool. So the framework that we are working is how to determine a global impact of a CAT system, a connected and autonomous transport system. Well, the approach that we propose is try to understand at microscopic level, using microscopic simulation, the implementation of this connectivity and automation inside of the simulation model. And then try to derive what could be the effect at macroscopic level, at system level. So the methodology that we're applying is using microscopic simulation-based experiments. We derive the network capacities through the network macroscopic fundamental diagram. In that case, we determine the relationship between capacity ratios for using different penetration rates. These capacity ratios, then we identify the functional relationship, the PCU versus the penetration rate. And then is a kind of, let's say, meta model or a proxy to estimate, a grosso modo, of course, what could be the potential effects of the CAD systems inside of your city. At the end, using the PCU, we perform the analysis in terms of performance, travel time, emissions, etc. So in that case, the Levitate project is covering these three. We have data from these three models. So Barcelona, where we place a subnetwork of Barcelona city center. So the Bilbao, that is in the north of Spain, and the Manchester city. And Athens is not there, right? The idea is try to understand with different configurations, different type of networks, different cities, different countries, whether we can transfer in that case, the PCU analysis that we can do in Barcelona, whether it could be transferred to Bilbao or to Manchester, and what could be the relationship between them. Is an ongoing process, it's an ongoing work that we try to scale up and transfer between different cities and have as a grosso modo the relationship between AV penetration rate with different services and performance of the system. Another domain is Save Up Project. Save Up Project is a big project where the main car manufacturers are there. So we have Audi, we have Bosch, we have Toyota, we have IDIADA, and then other research partners, Third, ICA, Chalmers, TNO, TU Delft, Firenze, etc. So the idea of the main objective of Save Up aims to proactively address the upcoming safety challenges by developing innovative technologies and assessment methods. So the idea is part of this project is improve the current behavioral models, especially for human drivers and vulnerable road users, stressing the interactions on the future interactions with AVs. And then once we have this simulation framework combined with other simulation frameworks, the idea to identify future safety critical interactions in order to analyze in advance what could be the potential corner situations that automation should solve for the connectivity and autonomous vehicles. At the end, the Safe App is, we are going to use a simulation environment of AIMSUN Next, where we are going to jointly plug different external behavioral models for vulnerable road users, bikes, pedestrians, two-wheelers, plus human drivers, plus the interactions with the AV stack, right? So the idea is to combine and define as a pool of use cases where all these behavioral models are going to interact and assess metrics related to the safety. On the other hand, we have this more global view. So how the mobility is going to perform, that is Harmony. So Harmony is the main solution is to provide a model suite, a platform that is going to bring together transport and spatial planning tools, passenger and freight activity-based models, network models, and land use models. At the end is the combination of different methodologies, different models, and the interaction between them. As I mentioned before, the multi-tier models is something that is there, and it's a research line. At the end, an outcome is going to provide for the authorities and the road operators training materials to develop their skills and knowledge in an integral way the mobility in their city. At the end is this is what is trying to develop Harmony. It's a 3 years project, and we are in the middle. So we have the integration of the strategic simulation models, tactical simulation models with operational simulator models. So at the end is how we can have a common framework where the exchange of data and the exchange of inputs and outputs could improve globally the assessment of any policy related to the mobility. One aspect to mention here is the fact that we are going to these data requirements, because this simulation platform will be very data hungry, because we are going to have disaggregated demand, trip change, individual vehicle movements, passengers plus freight. So at the end, we will require a lot of data that potentially is there and has to be exploited to solve these three levels of simulation: strategic, tactical, and operational. In that case, our role is provide the operational level where the simulation is going to be in charge of reproduce the short-term prediction, where different fleets are going to interact at the same time with the background traffic. So that means passenger, goods, and combine it with public transport. So there is a concept of multimodality. There's a concept of fleet operators. So algorithms that is going to to schedule the pickup and delivery of the goods. When there is a request of a trip from origin A to destination B, the possibility to offer different services with different fleets, so Uber, Lyft, or ride sharing, or bike sharing. So the possibility to have a simulation environment where all what we call external controllers could be plugged and evaluated at the same time as a unique answer, and not independently to one by one. And for ending this review of our modest contribution to what's going on is Momentum Project. Momentum Project is focused on how to exploit data. So the current data, for instance, mobile data, ride sharing and service data that is available, how to improve the strategic models. So it's a combination of transport and data-driven predictive models in order to support the policies to be implemented at a metropolitan level or a planning level. Okay, so in this project that's we are involved, we already detect some models that we need to improve. When I'm saying we, is in general the consortium. So in terms of the demand, so we need to improve at the strategic models how to deal with incentive and regulatory schemas, how to decide the price of the share mobility. So in that case, we need to add more algorithms, more models to represent better using the current data, the mode choice, the OD demand, the concept of multimodality, etc. Oops, sorry. In terms of the supply, we are working how to improve the strategic models in order to deal with these new mobility schemas. So one line that we are exploring is how to have this, the traditional static traffic assignment, how to put these dynamic models, let's say dynamic traffic assignment, where we have a better representation of the queues and the spillback, so better estimation of the travel time, in order to provide the feedback information to the demand in order to decide what, well, parking regulations, lanes regulations, etc., etc. On the other hand, one aspect is how to model fleet management in these strategic models, opening the window that these strategic models could be dynamic. So how we can develop algorithms to determine the operator of a fleet. So the position of the vehicles, the charging, the schemas of anticipating the demand. So aspects related to ride sharing, bike sharing, micromobility. So the selection of the different services. And at the end, there is the last but not least is aspects related to accessibility and network coverage. So try to deal with social aspects. And also, as I mentioned before, aspects related to fuel consumption and emission. In that case, the fuel consumption and emission, the consortium is planning to have more data-driven oriented, not going through models, collect data with emission sensors. And with these emission sensors, then try to have a kind of meta model, because then this meta model could be integrated in a traffic transport model. Okay, that's the idea of momentum, is at level of a strategic level, how to increase the functionalities and have a better accuracy on the answer that is providing. So, as a summary, and I try to just squeeze all what we discuss. And this is a kind of, considering all research projects that we're participating, the different proposals that we submitted, the different proposals that we are working. So at the end, there is some, let's say, at least some kind of consensus between different people is, well, the combination of transport models and data-driven models is there, and we believe that it is going to leverage a lot the answer that this type of models is going to provide. There is no unique model. The combination of different models, so multi-resolution models for larger scale models should be a solution. Is the only way to deal with larger scale models. We need to deal with how to transfer the scalability and the transferability of these complex models to a macro level, so a more strategic level, how to, let's say, simplify and determine the trends at macro level to take decisions. Reproduce emerging mobility concepts in transport model. So we need to explicitly include all emerging mobility concepts, for instance, connectivity, autonomous vehicles, the electric mobility that implies the charging points, etc. So there is a need, and is especially for the cities, the simultaneous modeling of the passenger and freight demands. So the freight, the goods, is something that we cannot treat separately, especially with the new e-commerce that trend that we have. And at the end, and this is more crucial, is identify uncertainty in data, scenarios, and models. So the people has to understand that the models are based on hypotheses, and the hypothesis implies a scenario. So deal with uncertainty is something that is there, and we need to exploit, and we need to explain, because the transport models in general are not black boxes that we press a button and you get an answer. This is a kind of thing, or thoughts that we can, let's say, express here. Of course, there are a lot of other, but I think I try to summarize what I already experienced in current research project that we are working. Thank you.